So let's work this problem out. Here's what we've got. We've got a crate that's sliding to a stop. So it's got a mass of 10 kilograms. Its initial velocity is 15 meters per second. The coefficient of friction is 0.5, and it slides to a stop. The angle of incline is 25 degrees. And I want to know how far will it go up that incline before it stops? Okay. So, well, let's solve for it. I want delta x. I know the velocity, so I'm going to have to use kinematic information to figure out delta x. So you want to look at the kinematic equation. Now, in this stuff, you can assume, hey, I can figure out what the acceleration is. So assume that you have acceleration. So you're not going to use the second kinematic equation. That's the one that doesn't have acceleration in it. Now, you don't have time, and you don't really need time, so find the one that doesn't have time in it, and that is the final velocity squared equals the initial velocity squared plus twice the acceleration times delta x. See, I know this, I can find the acceleration based on forces, and I'm looking for delta x. So let's solve for delta x. I'd say delta x is equal to, well, the final velocity is 0. So we're going to subtract this to the other side, negative v naught squared, divided by twice the acceleration. So I know what this is, but I don't know what the acceleration is. So if you approach this by solving for what you're trying to find, the problem kind of tells you what to do next. Okay, now I need to figure out what the acceleration is. Well, I have to use forces to do that, so now I have to use the procedure. So I've already got given, find, and solve. I'm trying to find the acceleration. So let's draw a free body diagram. Here's my crate. Here's gravity. Here's the normal force. Oh, F sub n. Okay. And then you have the force of it's sliding up the incline, so you've got kinetic friction holding it back. There's your force of friction. And we'll make up the incline positive. Here's x, and here's y. And so I'm going to break up the force of gravity into its normal component, which is always mg sine theta. I'm sorry, cosine theta. Right, because it's adjacent. And then pulling down the incline parallel to the plane is the parallel component of gravity, which is mg sine theta. Right? Theta is the angle of incline. If I incline this up by 25 degrees, I incline this up by 25 degrees. So this is the opposite leg of a right triangle. Therefore, this is mg sine theta. You need to know that. Now I can sum the forces in the x direction equals ma in the x direction. Well, what have I got in the x direction? I got negative mg sine theta. Why the negative? Because I said this direction is positive, so down is negative. Minus the force of friction equals ma. So A is going to be equal to negative mg sine theta. Now, what is the force of friction? The force of friction is equal to mu times the normal force. Well, mu is 0.5. But what is the normal force? No.
Oh, wait, because it's not up and down?
So here's your normal force. What is it doing? It's canceling out the normal component of the weight. And there's no other forces in the y direction. So this normal force has to support this component of the weight. So the normal force is equal to mg cosine theta. So minus mu mg cosine theta. So this is mg sine theta minus the force of friction, and then divide by the mass. Now notice that I left everything in variables, didn't I? I didn't plug in any numbers yet. You see anything that goes away? Mass goes away. It's in every term, so it cancels out. What that means is that I gave you the mass of the crate, but you didn't need it. You could have solved it without it. So the acceleration is going to be negative 9.8 meters per second squared times the sine of 25 degrees minus mu, which is 0.5, times 9.8 meters per second squared times the cosine of 25 degrees. So there's a lot of arithmetic here. And so what is the acceleration? Let's plug all this in. It's going to be negative. And so just typing all this in. Now I get 8.58,
Yeah.
negative 8.58, rounded off, meters per second squared. And now all I got to do is plug it in here. So delta x is equal to negative v naught squared divided by 2 times negative 8.58. So delta x is equal to, let's see, I got 13.1 meters. If you got that, that's good. This is a pretty difficult problem. But I think you can see the whole flow of it. Using kinematics to solve for my unknown, but then I need the acceleration, so I use force to figure out my acceleration, and then I plug that back into kinematics, and then I get how much it slides up. Any questions? Yeah, because this was a challenging one. Okay, that is all.